Awesome. Cool. What an amazing topic we have today, right? So, I've been working in data analytics for quite a few years now. And after the hype of big data and machine learning and blockchain, right? So the data warehouse is still there. So having data warehouses, building data warehouses is still as critical as it was 40 years ago. So the idea for today pretty much is to be able to discuss and show you actually a few key concepts within data warehousing and business intelligence. Also, we'll go through some architecture diagrams to see how we can assess if that architecture diagram is a data warehouse or not. But before we kick off, I'd like to thank the sponsors. It's really difficult to organize an event, and it's really difficult to find the sponsors. So I'd like to pretty much mention them. It's really important. And thank you to the organizers. Running an event is not as easy, finding the speakers, doing all that marketing, finding the attendees for the event, and putting all the effort that goes in. And most of the times, all this effort goes in with their free time. So thank you to the organizers. A little bit about me. I'm based in Brisbane, Australia. Thank you to Rocio and Cecilia for warming up this Spanish accent before. So you're going to get the second part of the Spanish lesson today, which is really important. And yeah, working in data analytics from 2011, there has not been a year where I didn't work in a data warehouse project. I've been building, designing, and implementing data warehouse projects across different organizations. And I want to share a few tips and tricks today, but also some key concepts that I think you're going to find valuable. Don't forget to get involved with the community. I remember giving my first presentation 4 years ago. It's going to be 4 years ago and 10 days or something like that. So if you're looking to, if you want to share something that you're working on, or share your expertise, or share even some challenges that you had and how you overcame those challenges with the community, feel free to reach any of the organizers. And I'm sure that they're going to help you finding a spot where you can give a presentation. Hey, if you don't want to give a presentation, try to get involved with the online community, with the different blogs that are available. And if you don't have time for that, that's all right. Try to get involved within your own company, okay? The community within your own company. Having those learn and launch sessions once every 2 weeks or every week, that'll be great. Mentioned before, the agenda for today, pretty much some key concepts of BI and data warehousing. Then we'll go to methodologies. We'll talk a little bit about roles and the demand in the market. I feel that some of you'll find that information useful. And finally, we are going to review some data warehouse platform architectures and assess them to see if they meet our data warehouse definition. Feel free to put the questions in the chat as we go, but I'm not able to see the questions. So I hope, Cecilia, feel free to stop me and ask any questions that attendees put in the chat, please. BI. So this term comes a long way. So I think the first reference, if you go to Wikipedia, you'll find that this is from 1860. I think not many of us were around by then. So the one I picked up is one that you're going to feel familiar with because it's from Ralph Kimball. Within the data warehousing context, of course, right? And the applications. The term BI application refers to a range of capabilities provided to business users to make pretty much those business decisions through a presentation layer. This is really key. I think the key words within this amazing definition is like provided to business users. That's the main one. Don't follow a different path. Well, if you are working in the business intelligence space, you are building data products for your business users so they can make business decisions to either improve the performance of the company or make it more efficient or to decrease ongoing costs. So those things are really important. Remember, if you are working in the business intelligence space, it doesn't matter if it's in the data engineering side, the data analyst side, or machine learning side. All of you are contributing to build a data product that is going to allow those business users to make business decisions. There is an operational component. Most of those decisions within BI, they'll be strategic. They'll be at the board level, at the CEO level, CFO level, potentially managers level. And then there's a side effect. You can factor in as well operational decisions if you need to. There are quite a few BI tools that you know, that they go from Power BI to Tableau, QuickView, MicroStrategy, TIBCO, or this Google Looker that I haven't had a look, not yet. The offering is quite. It has been. There have always been like 10 or 15 companies that they have really good BI tools. I do believe that Power BI took over a big part of the market by the innovation and how they release features and how they made business users able to use BI tools. So I do believe that BI, from a BI point of view, so Power BI right now is one of the best tools, more complete tools within the market. And I don't believe that that's going to change in the coming 2 or 3 years. And if it change, just let me know, and I'll invite you to have. I'll pay for dinner or a few drinks, 100%. Now let's go to data warehousing. Data warehousing will be one of the key components within BI, right? So if you are looking to help your business users making business decisions, therefore having a good data repository, a single source of truth, that's going to help you a lot. Not having the data warehouse, you can still build a BI solution, a business intelligence solution, but having a data warehouse is a key component. That's why it's so important to keep it in mind. Big data doesn't replace data warehousing. Machine learning doesn't replace data warehousing. There's no anything that's going to replace data warehousing. Data warehouses, they're going to stay. They're here to stay. They have been around for 40 years. They're going to be here for the next 40 years. It's a framework. It's a concept. It's a design to centralize the information, to minimize ongoing costs, to minimize data duplication, to make sure that the integrity of the data is correct, to make sure that the data quality of the information is correct. All those benefits within the data warehouse, they're not going to change. Technology might change. We'll have more capabilities that we can take advantage of, but the data warehouse is here to stay. One of the best definitions for a data warehouse, pretty much, before we move on to that. So I'm going to mention, before we go into the definition, 2 key concepts that we need to take into account today. Is pretty much, the first one is how we're going to move the data to a data warehouse environment. You have 2 different approaches. You have the ETL process, where you extract the information from the source systems, you transform the information on the fly, and you load the information in your data warehouse architecture. And this is important, data warehouse architecture. I'm not saying the data warehouse database or data warehouse in Azure. Okay, so the data warehouse environment architecture, it could be made up of multiple services. And the second one is a different design for moving information that takes advantage of those but big data analytics or engines. That'll be the ELT process. So you extract the information from the source systems, you load that information as it is in your data warehouse environment, and then you transform the information after you have loaded the information there. The key difference is that the one on the left, this was the approach that we used, pretty much one of the only approaches or the main design for data movement that we used during the past, let's say, until 2015. After the rise of big data engines, we shifted a little bit to the second approach. So we take advantage of the big data, those new engines and the parallelism and the clusters, nodes, and all those things. So on the left side, you can think of SQL Server integration services, or even Azure Data Factory data flows, the mapping data flows, or you can even think of Power BI data flows. On the right side, you can think of pretty much of taking advantage here. The reason why we have the transform after we load information is to take advantage of the potentially a powerful engine like Azure Synapse Analytics SQL pools or a Spark cluster. To summarize this slide, I want you to know that there are two different approaches, that one approach doesn't replace the other one, that sometimes you're going to, in the same environment, you're going to combine the two approaches, and that makes sense. And of course that we move from ETL to ELT, and now we have new tools that use ETL, like Azure Data Factory mapping data flows, that they are supported by Spark clusters in the backend, that they're really fast. The data warehouse pretty much is, in a nutshell, at a really high level helicopter view that we're flying really high, will be to move the information from multiple source systems, from n number of source systems. It doesn't matter if the information is a structured, non-structured, or semi-structured, will be to move that information to a data warehouse environment. It could be, and we can think of having here a data warehouse database, a relational database. We can think of having a Delta Lake architecture, having a Spark, having a SQL Server database, having many things here, and then allowing out of that data warehouse, we can enable those BI capabilities so our users can make those business decisions. Now, do you need a data warehouse to have business intelligence capabilities? Not really, but the data warehouse is going to ease many of the pain points on not having when building those BI solutions. If you've been reading some of the books related to data warehousing, one of the best definitions that you're going to find is the one from the father of the data warehouse, Bill Inman. And he says that a data warehouse is a subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management decisions. Management decisions, that's important, but I'd like us to focus on the adjectives in this case. So subject-oriented, integrated, non-volatile, and time-variant. And I'm going to add two more that are mentioned in the corporate information factory written and designed by Bill Inman, Claudia, and Ryan 30 years ago. Subject-oriented will mean that, and remember, this will be the 6 main characteristics that will help you assess if you are building a data warehouse, and if the technology that you're going to use is going to help you achieving that data warehouse environment. From a subject-oriented point of view, data work implies that the organization is organized in the key entities for your company. You can think about organizing that information from those operational systems, those application databases, or any source of data. You can organize that into customers, products, vendors, orders, policies. You can think of many examples. So what you want to do, whatever your application, whatever application they are using from an operational point of view, you want to make sure that when you move that information to your data warehouse environment, you organize that information into the major entities of the corporation. The second one, your data warehouse needs to be integrated, and you're going to feel familiar with, because it's pretty much the physical unification of all those data sources into a data warehouse. And by organizing that information and putting all that information into the same environment, you want to make sure that you apply the key structures, naming conventions, relationships, data modeling as well. And you'll see in a few slides, there are different types of data modeling approaches that you can follow, but you want to make sure that you apply those practices in that step. It doesn't matter if it's structured, semi-structured, or unstructured information, right? All that information can be valuable for your business users, and it can be valuable to have that information into a data warehouse environment. Of course, having unstructured information or video files or audio files in a relational database, in a highly transactional database, putting those video files or audio files in a SQL Server database, for example, or Azure SQL DB, it's not the best idea. That's why you need to think out of the box. So think about an environment. So if you have a data warehouse environment and you know that you want to put the structured information into an relational database, so you might put that non-structured information somewhere else. So you might put that information into a data lake, for example. The information needs to be non-volatile. Records are not going to be updated they're not going to be normally updated in the data warehouse. New data is going to be appended within your data warehouse repository. There's no black or white here. There are many options as well. So you are going to define that some of the entities, for some of the entities in your data warehouse, you like to append information. For some of the other entities, you're going to decide that there is no value on appending data and you're going to replace the data. But certainly what you need to take into account is that your data warehouse should have this capability. If you use another capability, that's a different conversation. But your data warehouse should have this capability, because eventually you are going to be taking advantage of that capability. And I'll give you an example. Let's say that we move from a source system to a data warehouse, order A. So that will be the first record. So we extract the information from the source systems, we put in data warehouse, we have the first order. Then we do the same with order B. And eventually we do the same with order C, right? So now we have 3 records in the data warehouse, and those 3 records, they exist in the source system. So finally, let's say that let's say that order B had some issues, or we need to cancel order B. So potentially in some operational systems, what it could happen is that they remove order B from the source system. In your data warehouse, you're not going to delete that record. You might flag that record as deleted. This is an important difference when you think about building the data warehouse just using Power BI, from source systems to Power BI. Okay, so this is a really good example that we can feel familiar with. Next is time variant. Any point of time, the information needs to be accurate in the data warehouse, right? So if you are looking at information from 20 years ago, so why the information that you get out from your data warehouse needs to be a snapshot of the state of that information 20 years ago. If I can give you an example again, so let's say that we have customer one who lives in New York City. When we move that information to the data warehouse, so we'll identify that customer and we get the demographic information, and we'll say that, okay, that customer, as we know, we think that has been living in New York City from January 2010. Now let's say that that customer moves to a different city. The customer moves to Madison. So if the customer moves to Madison, what we're going to do when we gather that information is that we're not going to replace the city here, because you can think we might have a lot of orders. If it's a retail company, we might have a lot of orders from that customer in New York City. So there is no point of us of replacing the information for all those orders until having the data warehouse that he was living in Madison. So what you're going to do in the data warehouse, you're going to create a new record. Concepts that are related to this, there'll be the slowly changing dimensions, right? But we don't need to go to that to start talking about those topics yet. Again, think about this feature. So we need to have this feature and capability in the data warehouse, right? So we create a new record and we tell that the customer is now living in Madison, and we flag the previous record as a today record. And you can add more columns as to its current record, and you can add some more metadata columns. But you can see here that we're not replacing the information. So we know that our customer was living in New York City until 2015, and then he moved to Madison. So we're able to get accurate information from any point of time in the past. And I'd like to add there are two more characteristics. One will be historical data. We need to be able to capture as much information and to go to the past as much as possible as the business has defined, right? So if we need to capture 10 years of information in the data warehouse, we need to be able to do it, as well as if we need to capture 100 years, because we have some compliance rules that we need to meet, and we need to keep some PII information for 99 years. If we don't do that in the operational systems, we might do that in the data warehouse. So we need to capture historical. We need to be able to capture as much information as we want into the data warehouse. Most important, a change in the operational system in one of the source systems shouldn't affect the historical information in your data warehouse. So if you are using point of sale systems or a specific payroll system or any system that you have in the source system, okay, if you change the application, that shouldn't affect the historical information into your data warehouse. And finally, we need to have summary and detailed data. Summarized data is not enough, so we need to have detailed information on the most atomic level possible. So we need to have the most granular information of the data available in the data warehouse to allow our users to ask questions like why, when, what happened, when did it happen, right? So when you offer in a Power BI report a KPI, and the KPI says that the revenue of the company is down 20%, So they're going to need to ask those questions and answer those questions. So they'll need to drill down to a level of more detail of information to be able to answer that information. So these were the last characteristics. All these characteristics, you can find them in the Corporate Information Factory. It's a great book, and you've seen at the very minimum 6 characteristics, what allow you to think of as well that these 6 characteristics pretty much they apply to any data warehouse. It doesn't matter the data modeling approach that you're following right now. So these 6 characteristics, they'll apply to the Kimball methodology, to the data vault methodology. They apply to any data warehouse that you are working on or you are starting to design or implement. Therefore, we don't need to mention those methodologies. There are many of them, but I'd like to highlight 3 key data warehouse methodologies today. The first one will be the one from Bill Inman. The enterprise data warehouse is highlighted in the Corporate Information Factory. So the data warehouse is the key component of that. Corporate Information Factory is in the middle. We're going to go on expand a little bit what this means. The next one is the one that if you're working with Power BI and you think about the star schemas and dimensions and facts, you're really familiar with, that will be dimensional data modeling from Ralph Kimball. And the last one will be Data Vault 2.0 by Daniel Lindstedt. So those are 3 key methodologies within the data warehousing that you can take advantage of, that they have been proved. It has been proved that they work. And we also have a lot of information about their limitations and their advantages. So that's really important. If you understand, I always say this, it doesn't matter what you're doing or which technology you're implement, make sure you understand the limitations. If you understand the limitations, you can work around. You can mitigate those limitations and challenges. If you don't understand the limitations of a product, a methodology, a framework, you're going to run into those challenges. I try to summarize as much as possible these 3 main key methodologies. Doing that in one slide is really difficult, but I'll highlight some of the key characteristics within each methodology. Within Bill Inman methodology, the data model is normalized in the enterprise data warehouse using entity relationship. That means that you can think about, in this case, we're not talking yet about dimensions and facts. Okay, this will be a traditional ER model. Because it's a ER model, we can easily remodel entities as required and apply changes. And we can make sure that there is little or inexistent data duplication. One of the key differences with the other 2 approaches is that in Bill Inman's approach, we need to think about having, before we build data marts or we enable BI capabilities, we need to have a complete view of the organizational data. We're following a top-down approach. That means that dimensional data marts are created only after we have a complete data warehouse of the organization. The complete data warehouse has been created. You can think, okay, if we need to build the whole data warehouse for the organization and then enable BI capabilities, that's certainly one of the key disadvantages that we need to highlight. There'll be a big upfront investment. And then it's recommended actually that you still need to go and build those data marts. And it's recommended that you need to go and build those data marts using dimensional data model. That will be our next example with Ralph Kimball. So give me just a second. Are there any questions in the chat?
No questions so far.
Questions? Okay, just give me And we go back to. Now then we can do all this video editing, you know, and then we put this amazing YouTube video, right? We can cut this section. Joking. Cool. A good example of data modeling within Billing Mode. So you can think of having, you can see here, this is our enterprise. This is just an example. Enterprise data warehouse data model design within corporate information factory. This is not the data mart. But you can see that how the information is using entity relationship model, and if we need to answer a question like, I want to know, the question is, can you tell me how many bookings we have per airline for tomorrow, right? And how many we have of them? You can see that we need to answer that question. Pretty much, we need to go to. We need to pick up the bookings. We might not need the customer information, but let's say we need to pick up the bookings, the flights, then we need to pick up the aircraft. Here we have the airline codes, but we need the airline names, and we need to go to this table here, right? You can see that we need to join 4 tables to answer this question. I might highlight that within the corporate information factory, it's not recommended to build reports out of the enterprise data warehouse. You'll build data marts on top of this. The next one will be the dimensional data model by Ralph Kimball. This is the one that I've been using pretty much every year. And it works, it's great. So you know that you're going to normalize the information into facts and dimensions. You can think about the star schema at this point of time. You're also going to be able to build, deliver incrementally your data warehouse really fast, which is really good. With fast, I mean depending on the capabilities within your team and organization. But delivering value to the business in any of those these 3 key data warehouse approaches needs to be as soon as possible. That's how it is. If you are thinking about waiting 6 months to deliver some value within your data warehouse, I suggest to maybe plan ahead and try to deliver value as soon as possible, so you can engage your business users and you can deliver more value. Because you are denormalizing that information only into a few tables, it's self-service BI friendly. That means that if you're thinking about enabling self-service business intelligence capabilities, this model is quite good. It's really easy to understand. The main entity, the star schema, really easy to follow for them. The business user doesn't need to understand about dimensions and facts. Okay, that'll be you. That'll be the IT expert. So you follow a bottom-up approach. That means that you're going to create data marts incrementally within your data warehouse environment. You create one, and then once that you create in the second data mart, you have some dimensions that are shared across those data marts. Good examples could be the date dimension that is going to be pretty much shared across most of your star schemas, or it could be a customer or demographic entity. Some disadvantages, pretty much you're going to duplicate data because on how you are denormalizing information. The good news for us is that this is not as important. You know that storage, and keep this between us, storage is cheap. Okay, especially in the cloud, it's cheap. And then on top of that, it's not that it's cheap, it's that you have products like Power BI, which is using column store indices, or you have Synapse SQL Analytics, Azure Synapse Analytics SQL pools that is using by default column store indices. You have Parquet files that is using column store indices. You have all the big data major technology providers like Spark that they take advantage of reading information from column store indices. column store indices is going to highly compress that information, even if it's duplicated, especially in the case of strings. And the other challenge, maybe it's difficult to remodel. It's true that every time that if you have an entity, a dimension, the customer dimension, and you're planning to add more attributes, that becomes difficult to manage within dimensional data modeling, right? Every time that you need to add attributes to the customer entity, you'll find that it's not as easy as in the Immon approach or the Immon approach or the data vault approach by then. Good example of a star schema. If we need to ask the same question as before, right? How many bookings we have per airline company at any specific point of time? You can see that pretty much our customer booking table is in the middle, and we just need to join airlines in this case and join with a customer booking table. This is the recommended approach for doing data modeling in Power BI, because all the reporting tools, all the business intelligence tools, their performance is better by using this approach. Now, as I mentioned before, even if you go and build the enterprise data warehouse following a top-down approach, you still need to build those data marts, and those data marts are going to follow this dimensional data modeling approach. And finally, data vault. That is great, and is great because it was created considering some of the limitations that we have in the Kimball and Immon approaches. It stores the information, it stores raw data, and you can think about storing a copy of the information from your source systems in your data warehouse environment, and then we build the business vaults with the business rules, and we enable a reporting layer for our business intelligence capabilities. It's going to store the information into hubs, links, and satellites. We'll see an example in the next slide, but pretty much your hubs and satellites are your dimensions in dimensional data modeling, and links and satellites are your facts in the dimensional data model. Data Vault 2.0 is a framework. It comes with a lot of suggestions on how you can handle incremental build and agile methodologies. Within Data Vault, it really is actually to build everything incrementally. Do you remember the previous example, the challenge that we have if we want to add more attributes to the customer entity in a dimensional data modeling? So we won't have those challenges in Data Vault. So it is designed and created to mitigate some of those challenges. Then you still need to build on top of, when you think about your reporting layer, you want to be using pretty much creating those data marts and following the dimensional data modeling approach. What you're going to find that many times your reporting layer in the Data Vault will be a set of views that make the information available for your reporting tools. It's also done factored in a couple of capabilities that are really important. He factored in things like big data and real-time ingestion. That when 40 years ago, that was not a thing, right? But nowadays, when the volume of data is just increasing and is going to continue to increase in the upcoming years, so it's really important to understand that Data Vault did factor, and you have options and design approaches to work with big data, large volumes of information, as well as real-time ingestion. The main key disadvantage that I'm going to highlight here are difficult to develop and manage by a small team. I'm based in Brisbane, Australia, which means that many of the organizations in Australia, they are not medium or big as in the USA, correct? So many of the organizations here, they're pretty much small, and they might have a team within the data analytics space of 1, 2, 3, or 4 people. So it'll be really challenging for them to be able to manage a data vault ecosystem with only 1 or 2 people. Can it be done? Yes, it can be done. I'm not saying that it can't be done, okay? But this is something that we need to consider. And also there is it takes more time to build a data vault model than building a Kimball dimensional data model. Now, if you think future-proof as well, maybe data vault might be the way to go. But from what I've seen in the past few years, I've seen a few large organizations that they have implemented data vault, and those ecosystems, those environments, they are supported by multiple people. We're talking about teams of 15, 20, 30, 40. Yeah, 10, 15, 20 people supporting the data warehouse ecosystem. Those teams that are 1 or 2 people, I've seen them following a dimensional data modeling approach. Example for this might not be the best picture, but really nice picture that you can query at this website. Remember, so your hubs and satellites are your dimensions. You have your customer hub and the customer attributes. They're in a different table. And for the fact tables, you have the delivery link, right? With the other hub and satellite will give you the information about when an order has been delivered. So if you want to ask a question here, for example, how many products we have delivered using common mail posts, and to which customers. So you need to be querying pretty much these 4 tables from here, which won't perform as good in a Power BI report if you import the model as it is. So what you'll do is you'll build on top of this, you'll build some views, a reporting layer, or your data marts that they're going to present the information in a star schema approach. That will minimize some of the key points. The benefit is that by using the hub for the customer, for example, if you want to add a new set of attributes, you can put that information in a different satellite. That's important. You don't need to modify this table from here, so you will add a new set of attributes in a different satellite. So that one makes applying changes within your data model easier than it is in the dimensional data modeling. If you have any questions, just put them in the chat and feel free. I'll try to answer them as we go. Now, data warehouse roles and demands. So you've seen in the previous session a few of the roles that have been mentioned. The market has been changing a little bit during the past few years. There are many roles that they can end up working in a data warehouse environment. You're going to find that the concept of ETL developer, you're not going to find as frequent as you did a few years ago, because it's changing to data engineer. So you can still have a data engineer working in a data warehouse environment. It's just a new name, and it's true the data engineer might need to have more skills to cover things like machine learning data engineering, so preparing the data for the machine learning developers. But then we have the data warehouse developers, BI developers, data analysts. You have DBAs, data architects, data warehouse architects, database developers, data scientists, machine learning developers, and engineers. Now, any of these roles could be working at the very minimum in a data warehouse solution or environment. During the past 10 years, I met many people who when they're trying to find a position or a job, they're looking for a data warehouse sort of a offer. So And as I said before, so maybe your key takeaway for this slide here is that data warehouse environments are here to stay. It doesn't matter which technology you are using on top. So the market is going to continue to grow. The main difference between a data warehouse right now and a data warehouse 30 years ago, one of the key differences is that nowadays, any company, any small company can go and start building a data warehouse incrementally because the technology is accessible to them. That's something that was not available 20 or 30 years ago when they had to buy a lot of hardware upfront. They had to make a huge investment to build a data warehouse. So nowadays, if you want to build a data warehouse, you can go and take advantage of cloud technologies, and you can spend as little as you want based on your requirements. That means that we have, from a demand point of view, there is a new group of companies, those small to medium-sized companies that now they have the technology accessible to them to build a data warehouse. That means more demand, right? So more companies needing a data warehouse will mean more demand. And certainly within IT, you know that there is a shortage of skills. So it's really good area to be seeking new opportunities. That's how it is. And I don't know about the USA, but from what I've seen, salaries are just going up. They're ramping up, and that's not going to change. Right now, there's a shortage of skills. So if you're looking for new opportunities, 100%, you can start exploring data warehouse solutions and opportunities. And I want to share a few resources at the end of the presentation with you, some books that might be helpful. Now, remember those 6 characteristics of a data warehouse? So we have 6 different characteristics that can help us assess if we are building a data warehouse or we're not. So I put a few slides with different architecture examples, and we're going to go one by one using those characteristics. The first one is an easy one, right? Can we build a data warehouse in Excel? So let's go and assess it. So can we make it subject oriented? Yeah, potentially, right? We can extract information from the source systems, and we can organize that information applying some minimum naming convention rules in our spreadsheet. Can we integrate data from multiple source systems into an Excel spreadsheet? I think no. We're going to find that extremely challenging. It won't be the way to go. Can we make changes and apply those changes within the Excel spreadsheet? No. Information is not volatile. It's not invariant. We cannot have historical data, and we cannot have summary and detailed data, right? We think about the spreadsheet. We can have, I believe, we can still have around 1 million rows. We cannot, if we want to push 10 billion rows within an Excel spreadsheet, we know that that's not going to work, correct? Let's go with the next one. You can guess which one is the next one. It'll be Power BI. Can we build a data warehouse in Power BI just by importing the information into Power BI? Right? Imagine that because Power BI offers a lot of connectors. Fair enough, right? We have more than 100 connectors, I believe. So potentially we can bring information from all the systems and put it in Power BI, a single Power BI report. So subject-oriented, yes, why not? Is it integrated? Yeah, we can integrate information from multiple source systems, right? We use Power Query, multiple connectors. We do some data cleansing, integrity rules. We create some measures within the rules. We can do those things. But then when we start thinking about non-volatile, we're going to struggle, right? What happened when they have deleted some records from the source system? Do I have the capability in Power BI to flag those records as deleted? No, we cannot do it. Same challenges we have with slowly changing dimensions or time variant information. So can we create slowly changing dimensions in Power BI? Can we append a new record? Do you remember the example? A customer moved to a new city. Can we do that? Certainly, we're going to find that quite challenging. Historical data, there'll be a limit, and if the source system changes, that's going to have a really big impact in our historical information. So imagine that we change our point of sale system to a new application. So it'll be quite challenging for us in Power BI to not to lose the information from the previous system. So we need to do append, and merge between queries, and disable the refresh for some of those tables. Quite challenging. And we can definitely have summarized and detailed data. That's not a challenge for Power BI. Next up, can we solve it by adding Power BI data flows and shared data sets? We're going to run into the same challenges, right? When we start talking about non-volatile information, time variant, and historical data, based on the previous examples, we're going to have some challenges. So how can we overcome those challenges? Can we bring some enterprise tools from Azure? What do we bring Azure Data Factory and Azure SQL DB? Potentially, you'll see that now we're going to tick all the boxes, right? So we need to build it and design it and implement it. We need to do all the things, but potentially with these capabilities, or it could be a SQL Server database or an Oracle database or Informix database, we can go and do the things. Between technologies, there'll be differences, right? And it's not the same an Oracle database than a SQL Server database. It's not the same an Azure SQL DB than an Azure Synapse Analytics SQL pool. Things are just different. Designs are just different. Let's say that we want to include a data lake, right? All of them, they can be, when you start looking at this one here or this other option with Azure SQL DBs, or we look at this one, now we implement the data lake and we move the data with Synapse pipelines, and we have a SQL pool. All of them, they tick all the boxes, right, for being a data warehouse environment. Even when you start thinking about data lakehouses, a concept that was introduced only a little bit more than a year ago, we start thinking about Delta Lakes and Databricks. All of them, they tick all the boxes for a data warehouse environment. You need to assess which capabilities you are seeking, right? What the volume, things that are going to help you defining which technology you use. It'll be things like a volume of data. It'll be like data volume increment per year, or it'll be, if you want to build a future-proof platform. You have many things that you need to factor in, but you'll be able to build data warehouses with different technologies. You don't need to go and follow the latest design approach that was made available to the market. You don't need to build the data lakehouse. You don't need to go and implement a data lake if you don't need to. But think about building a data warehouse environment. That's why I said at the beginning of the session that technology is going to change, right? And we have new technologies, and there are many technologies that you can use to build a data warehouse. But the concept of the data warehouse, the characteristics of a data warehouse, they're going to stay the same. Can you add more characteristics? Yes, potentially you can. But the definition of data warehouse that was made 30 years ago or 40 years ago is still valid. To summarize a little bit this session today, I'll share with you some lessons that I have learned in the past. And they do apply to any solution, actually, just not to the data warehouse solutions. The first one is, and it's something that you're going to find in life as well, is that if you fail to plan, you're planning to fail. right? If you fail to plan, you are planning to fail. And that is reality. It doesn't matter what you're doing, if it's professionally or your personal life. So make sure you have a plan, because things can go ungoverned and out of control easily if you don't take into account this great phrase by Benjamin Franklin. The next thing that I want to share with you is the PPT framework. Make sure that for all your solutions, you considered three main aspects: people, technology, and processes. Most times, technology is not a problem. You're not going to find challenges with technologies. Yeah, there'll be some limitations, and you'll work around them, and you're going to overcome them. Technology, we have a lot, right? So technology is more accessible than ever. We have more features than ever. Anybody can go on spin up SQL Synapse, Azure Synapse SQL pool with 60 nodes in the backend, right? But the main challenges that you're going to run into will be people and processes. And you need to take into account those other two key pieces of the puzzle. And what I found during the past 10 years is that most organizations, they have challenges with processes and people. It's not a technology thing. Stop saying that it's because the product doesn't work or because it's not what the vendor told us. It won't be a technology thing. It'll be mostly people and processes. And the last one, of course, fail fast, fail often, fail forward, right? So if you're going to fail fast. Don't wait 6 months down the line to fail with the project. That's why it's so important to try to deliver value incrementally. That way, you're going to be able to test or run a proof of concept or test if an approach has been defined correctly. Do it often, and fail forward means that learn something about it. Okay, if you're going to fail fast and learn something about it. Few resources that I'd like to share with you. Pretty much all of them are books that are available, I think, in the Amazon market, if you buy in Amazon or wherever you buy. They are great books. Some of them, they have been around for 20 years plus, but they're still relevant. Questions? I know that we are a little bit short of time, but we'll see how we go.